going to be looking at the merge sort. This is the third of the three sorting algorithms you need to be familiar with. This one is quite different to the other two, which is like why it's out on its own a little bit. So as a starter, you're given these two sets of dates. So the Daisy, Mo and Alicia, Nina, Malik and Andre got two different sets. Their birthdays have been put in order insofar as the academic year. So if you're born in September, that's near the start of the academic year, then December, then May. You can see how they're in order. Again, Nina is born before Malik, before Andre in the academic year. And you're asked how you would make one sorted list from these two sorted lists. And that will be the merge part of the sorting algorithm. We'll look at how they exactly do that later. So yeah, we're going to be going through that algorithm in some detail. And then there are a couple of worksheets where you get to kind of run it on paper. So the first bit that we look at is just this idea of merging two groups of items. And it's much easier to take two groups and merge them into an ordered list, into what if they are already two separate ordered lists. And so these are our two lists, and they are in order within each list by academic year, within an academic year, but they are not obviously in order as a whole, and we're going to sort that out now. So the way we're going to do that, and this is the merge part of the algorithm, is we look at the first item in both lists and decide which one happens first. So Daisy, born in September, is born before Nina, so Daisy gets put into the merged list. Then Daisy's taken out of list one. She's not in there anymore. Now we look at the next one. You've got Mo, and we're going to compare Mo to Nina. Well, Nina is born before Mo, so Nina will get taken off of list 2 and put into the merged list. Now we're comparing Mo to Malik. So Mo is born first, born in December, put onto the merged list, taken out of list 1. We now compare Alicia with Malik. Alicia is born before Malik, 9th versus the 28th, so she gets taken from list 1 and put onto the merged list. And now that we have run out of items in list 1, we can simply take whatever's remaining in list 2 and dump it on the end. And that is what we then do. And so our merged list is in order. We have one list in order from two separate lists that were in order, and that is the merge part of the algorithm. And so we need, that's the algorithm for one merging, and the activity 1 has you doing this with cards. As before, I feel like this was meant to be done on paper, and it's a bit of a faff to do in a document. So I don't need you to do this. I recommend you get a pack of actual cards and do this for yourself, kind of physically with the cards, just to be sure that you understand how this works. When you try that, you might start asking yourself questions about, how does this work? How does that work? You can either come back and ask me or have another look at the sheet. But I don't need you to do this actual worksheet because I think it's going to be a bit of faff. The next one you will do. So merging two lists of cards, there it is. And this is basically the answer. So we're starting at the left, we kind of go down the page, and then the right-hand column we follow on. So list 1, we've got 3 cards and 3 cards on list 2. And we pick the first one from list 2 is the 2 of spades. We put that on the merge list and we remove it. So the next go round, that one's been removed, and we're comparing the 4 and the 5. Well, the 4's next, so we remove that, put it on the merge list. Next up, we've got the 6 compared to the 5, so the 5 is going to go on the end, and then we remove the 5. So then swooping up to the next column, you've got the 6 compared to the 9. Well, the 6 is next, so we remove 6 from the list. Now it's the 7 and the 9, so the 7 is first. And then all we've got left over is the 9 on list 2, and we just dump that on. And so this last merged list is the result of that merge. So just do that physically, and ask me any questions if you're not sure how that works. So the merge sort as a whole has 2 phases. You have to split the items, and then you merge the lists. So we've looked at one run through the merge process, but actually you'll do that multiple times. But before we can merge sorted lists, we have to split our one unordered list into a separate tiny list that can be reassembled. So we're going to see how that works now. So you've got splitting, and then we merge them. So this is our input list. It is unordered. It is just numbers, nice and easy to deal with. We need to sort that list. So we're going to split it into two lists. Now you've got 1, 2, 3, 4, 5, 6, 7 items. So we'll have 4 items in the first half and 3 items in the second. Let's decide by convention that the extra item goes on that first of the lists. Okay, it could kind of go on either, but we're always going to put 4 items on the first, 3 items on the second list. But we have to recurse this process. We have to do it again. So our 4 item list gets split into 2 lists, each with 2 items in, and our 3 item list gets split into a 2 and a 1. So you can see they're the same data items, but now we've got several little lists, and we're going to split it one more time until we have 1, 2, 3, 4, 5, 6, 7 lists, each of 1 item. A list that has 1 item in it is by definition sorted. Once we've got to this level, everything has been split into the smallest parts. We do it recursively like this rather than in one go. Once you see how it's implemented, this will make sense. But that is the splitting phase, and that is now complete. So now the merging phase needs to take our 7 disparate lists and put them back together. And this is where we do the merge that we just saw before. So we're going to take those 2 lists at the start. They've got 1 item in each. So the first of those 2, we compare the first item in each list. Well, there's only 1 long. So we're looking at the 21 is going to go in first, then the 43. So we've merged those 2 lists into 1 list. Do the same thing with the next pair of items. So 14 comes first, then 50. Then 64 and 3, well obviously the 3 comes first, then the 64. 19 is this odd one out, so it just becomes another odd one out, and that's absolutely fine. We now go down a layer. We've got 2 sublists. 21 and 43 are in 1 list. They are now in order. 14 and 50, they are now in order. We now need to merge those into 1 list of 4 items. So the 14 is going to come first, then the 21, then the 43, then the 50. That's the same thing we did with the cards. So it just takes items off of the sublists and assembles them into that sorted list. Same thing with the other 2 sublists. We've got 3 and 64 and 19, and we will end up, when we merge those 2 together using that merge that we looked at earlier, 3, 19, 64. So now we have 2 lists, each one is in order, and we need to merge them together to make 1 list that's in order. And so we do the same thing again. So we look at the first item from each list and kind of keep popping them off in order until we end up with our sorted list, and that is the result: 3, 14, 19, 21, 43, 50, 64. The merge sort is complete. So, so you can see that each stage of the split is kind of splitting the list down and down into pieces until they're lists of 1 item each, and then you gradually merge them together until it all comes back together. So that's the split. There's the merge, and we go from that unsorted list at the top to that sorted list at the bottom. So here is the algorithm. Take the list of data to be sorted, repeatedly split it in half until each item is in a list of its own, and then repeatedly merge them together until you end up with 1 big list. So you're now going to execute this on paper in the worksheet. I think this one is okay as a worksheet to do on Google Docs. So I'll go and do the first couple of bits and show you how that works. You're just going to execute. Now, merge sort is an example of a divide and conquer algorithm, which means you give it a big problem and it breaks it into multiple small problems and then solves the smaller problems. So generally, that's what we mean. There are other algorithms that use this divide and conquer approach, just breaking big problems down into small problems and keep breaking them into smaller and smaller problems until they're so small that they're easy. And then you kind of bring it all back together. So a merge sort is generally a lot quicker than the other sorting algorithms that we saw, but it requires more memory because of all the new lists that have to be created. You can do it in place where it wouldn't take more memory, but it is inherently more complex to implement, but far faster, way quicker, especially on bigger lists. So as a summary, split the items into individual lists before merging them together in pairs and continually merging until it's together. Merge sort is a divide and conquer algorithm, and it performs well in the real world. Faster to execute, more complicated to write than, say, the bubble sort or the insertion sort. Takes up more memory because of all the little sublists. So there we go. Next lesson we'll be reviewing all of algorithms. Then there will be a big quiz, like an assessment. It's quite a big deal. So this is the last of the algorithms that we have to look at. Let's go and have a look at the worksheet quickly. So again, skip over the card one, just do that physically. We're going to do this one. So you are given this list of dogs. The splitting is done for you until you've got your individual lists with one item in each, and the first merge has been done for you. So you're going to merge these two sublists into this one list. So the first one will be like what, bulldog, then Maltese, that kind of idea. So you're going to do the merge of these two into this one list here, then merge these two into this one here. The answers are actually on the slides if you do need to go and look, but please make sure you satisfy yourself that you know how this algorithm works. And then you've got some questions about like how many merges took place and that kind of thing. I will be online for the whole hour. You can come and ask me questions. But once you've done that worksheet, just hand it in and you are done.